Hi, my name's Gabe. For this problem, we're going to consider the function f of x is equal to 2x divided by x squared minus 3x minus 4. And we're going to work through several things, but our goal is going to be to sketch the graph of this function. So let's start with part A, where we're asked to find the domain of our function. So looking at our function, f of x, we see that it's a rational function. So when we're thinking about the domain, we really want to think about excluding any of the x values which make our denominator 0. So let's go ahead and let's set our denominator, x squared minus 3x minus 4, equal to 0. Now this equation we can solve by factoring. So the left side is going to factor into x minus 4 times x plus 1. And we're setting this equal to 0. So if we solve this equation, we'll see that we have x is equal to 4 and x is equal to negative 1. So what this tells us is that our domain is going to be all the x values, or all real numbers, except for x equals 4 and x equals negative 1. So all real numbers except for x equals negative 1 and 4. Now, let's go ahead and let's find our intercepts. So let's start by finding the x-intercepts. So in order to find the x-intercepts, what we're going to do is we're going to set the y, or f of x, equal to 0 and solve for x. So looking at our equation, we're going to solve 0 is equal to 2x divided by x squared minus 3x minus 4. Now, since this is a rational function or a rational equation, this is only equal to 0 when this numerator is equal to 0. So the equation that we want to solve is 2x equals 0, solving for x by dividing each side by 2. We have x is equal to 0. So what this tells us is that our x-intercept is going to be the point 0, 0. Now, we can also use this piece of information to find the y-intercept because, well, the y-intercept happens when x is equal to 0, and we already know that when x is equal to 0, the function value is also 0. So our y-intercept is also the point 0, 0. Now for part C, we're asked to find any of the asymptotes. So let's start by thinking about the vertical asymptotes. So looking at our function, we see that it's a rational function, and the vertical asymptotes are going to happen when the denominator is equal to 0. And we really want to be careful here because I'm noting that the numerator and denominator don't have any common factors. If they did, we'd have to cancel first. But since they don't, we can go ahead and just think about, well, where is this denominator equal to 0? So we'll solve the equation x squared minus 3x minus 4 equals 0. And we actually already solved this when we did our work to find the domain. So we know that we're going to end up with two vertical asymptotes, one at x equals negative 1, and another vertical asymptote at x equals 4. Now, the other type of asymptote we want to look at is the horizontal asymptote. So the horizontal asymptotes are going to come from what happens as x approaches infinity or approaches negative infinity. So in this case, we see that the degree of the numerator is 1 and the degree of the denominator is 2. And since the degree of the numerator is less than the degree of the denominator, we know we're going to have a horizontal asymptote at y equals 0. So let's try to tie some of these things together, and let's plot some stuff on our graph, and then we'll come back to our table. So the domain, we can't do too much with the domain as far as sketching the graph goes. So let's come down and look at the intercepts. Well, we found that there's an x and the y-intercept at 0, 0. So let's plot the point 0, 0 on our graph. Next, let's think about our asymptotes. So we have vertical asymptotes at x equals -1 and at x equals 4. So let's go ahead and let's sketch the dashed lines on our graph for those also. So there's the vertical asymptote at x equals -1. We'll sketch the vertical asymptote at x equals 4. So what we know is that our function is never going to pass through these two dashed lines. And finally, we know that we have a horizontal asymptote at y equals 0. So let's go ahead and let's just draw that through here also. Now, something important to notice about this horizontal asymptote is that our function can pass through this line. It's just that as we move towards -infinity, so to the left, our function is going to get closer and closer to this line. And also, as we move towards +infinity, so as our x values move towards the right, our function is going to approach that line, y equals 0. So now what we want to do is we want to plot some points. So we want to think about plotting some points to the left of this asymptote, plot a point between our asymptote and our x-intercept/y-intercept, plot a point between our x-intercept and this asymptote, and then plot another point somewhere out here to the right of the asymptote x equals 4. So let's go ahead and let's start plotting some points. So like I said, the first thing we want to do is we want to find a point to the left of the asymptote at x equals -1. So let's think about taking the x value -2. So here we can throw this number into our function, or substitute this number into our function, and what we'll see is that the value that we get is -2/3, which is approximately -0.67. So what this tells us is that our function is going to pass through the point, or the graph of our function is going to pass through the point -2, -2/3, which will be somewhere about here. So next, we want to plot a point between our vertical asymptote and this point here. So let's think about x equals -0.5. So substituting this into our function, the value that we get out is 4/9, which is approximately 0.44. So we can go ahead and let's plot this point, -0.5, 4/9. Continuing along, we'll want to plot a point to the right of the origin. So let's plot a point somewhere in between x equals 0 and x equals 4. Let's just do x equals 1. And if we substitute 1 into our function, we see that the function value is -1/3, which is approximately -0.33. So we can go ahead and we can plot this point. And finally, we'll want to think about plotting a point to the right of the vertical asymptote at x equals 4. So let's go ahead and let's substitute in 5 for x. So substituting 5 in for x, what we see is that we end up with 5/3, which is approximately 1.67. So we can go ahead and we can plot this point. We'll come 5 and up about 1.67 will put us right about here. So now we have some information about our graph, and we have a couple points plotted. So let's go ahead and let's sketch the graph of our function. So what we want to think about is this idea of this horizontal asymptote. So as these x values approach -infinity, our graph's going to approach this line, y equals 0. So we can think about starting way over here at -infinity at 0 and staying close to this line as we move to the right. So what's going to happen is we're going to stay close to this line as we move to the right. We're going to go through this point that we found, so -2, -2/3. And as we continue to the right, we see that what comes up next is this vertical asymptote. So we can't touch this vertical asymptote, but we're going to approach it. So what's going to happen to our graph as we get closer and closer and closer to x equals -1 is we're going to keep decreasing without bound, so approaching -infinity. Now, once we get over to the other side of our vertical asymptote, well, we know that we have this point here, and as we start from this point, if we move closer to our vertical asymptote, we have to increase towards it, and we know that we can't touch it, so we're going to look something like that. And we know that the next point we're going to go through is the point 0, 0, so we can come down through that point. And we also know that we go through this point at 1, -1/3. And then as we move along towards the right, well, what's going to happen is we're eventually going to run into this vertical asymptote, and we know that we don't have any other x-intercepts, so we can't turn around and come back up. So what's going to happen is we're going to come over to this vertical asymptote and decrease. And then the next thing that we know is going to happen is that if we start at this point that we found, 5, 5/3, well, if we move to the left towards our vertical asymptote, we'll have to increase towards it, again, because we don't have any other x-intercepts, so we can't come down and decrease. And then, as we move towards the right, well, we know that we have this horizontal asymptote at y equals 0, so we're going to decrease towards this horizontal asymptote. So there's the graph of our function. Thank you.